Okay, I think now is a good time to get started. So welcome everyone. Thank you for joining us. My name is Michael and I'll be your host for today. I am a cloud solutions architect from Massdriver. Massdriver is a visual internal developer platform that enables engineers and developers to deploy production-ready infrastructure and application in minutes. During the webinar, our CEO, Corey O'Daniel, who's one of our co-founders of Massdriver, will be in the chat and Q&A rooms, as well as a couple other people answering any and all questions. This webinar will also be recorded and uploaded to the Massdriver YouTube channel. So today we'll be embarking on a journey to build our very own Azure Storage Account bundle. If you'd like to follow along with my webinar and build a bundle with me, that's great. I'm going to go ahead and paste some links in the chat that will help you do that. So I'm going to paste a couple more here. So the first link is to our Massdriver CLI tool. It works with both macOS and Linux. The second link is to our docs site, which will help you install the Massdriver CLI, as well as serve as an excellent reference for the commands that will run in this webinar. And we'll also have a reference to all possible commands for the CLI tool. The third link is our Azure Storage Account Application Assets GitHub directory. We're going to be using this repo as a solid starting point for our bundle. Massdriver is cloud agnostic. We do support Azure, AWS, and GCP. If you'd like to build your bundle for another cloud, please go ahead and do so. The only difference that you'll encounter is the Terraform that we'll be writing. Prior to the webinar, I did export my Massdriver API key and org ID as environment variables in my terminal. The docs link for the CLI will go over how to find and export these environment variables needed to use the Massdriver CLI. Here are the steps that we're going to follow today to build out our bundle. So we're going to generate a bundle template using the Massdriver CLI. We are then going to add some Terraform for our Azure storage account. We're going to modify the YAML file included so that we can add some params. And then I'd like to get any application connecting to my bundle to use RBAC for authentication. So we're going to create an artifact. More on that in a few minutes. And then finally, I'd like to be able to monitor issues with my bundle. So we're going to set up monitoring as well. So before we get started, let's briefly talk about some terminology that we'll be using during the webinar. We want to make sure that everybody's on the same page here. So what's a bundle? Bundles are a package of Terraform, YAML, JSON, and other supporting files that make it possible to deploy and manage cloud infrastructure using our platform. Bundles should be narrowly scoped to reduce complexity. We'll also create an artifact. Artifacts create connection rules for the bundles. They explicitly say what can and cannot be connected together. If my application expects a Postgres database, I don't want my team to accidentally attach a MySQL database instead. All right, without further ado, let's create a bundle. So I have VS Code here, and what I'm going to do now is run a Massdriver CLI command, mass bundle new. And what this is going to do is this is going to download some templates and then allow me to customize my bundle. I'm going to name my bundle Azure Storage Account Queue. And then it's going to ask for a description. We'll call this my private Azure Storage Queue. Now this is where I can select the template that I want to use for my bundle. We do have many application runtimes available if you wanted to build out an application. I'm going to select Terraform module. This will allow me to generate an infrastructure bundle. Now it's asking me to select some connections. Connections are required. They basically act as dependencies for my bundle. The only credential I know I need to deploy is the Azure Service Principal connection. So I'm going to look for Azure Service Principal. I'm going to hit the space bar to select it. And I'm just going to brief through here. You can see that we have many different connection types so that you can customize your infrastructure or your application as you need to. But now that I have my connection selected, I'm going to go ahead and hit enter. Now it's going to ask me for a connection name. So this is important because building bundles, you have the ability to use the same connection type multiple times, and you need to be able to differentiate between the different connections. We're going to call this Azure Service Principal with underscores, just like that. And then now it's asking me what output, what directory I want to output. So I'm just going to do current directory and hit enter. So now we have some files populated here from the template. We are going to go into the source directory and into the main.tf file. The main.tf file is what will host all of my Terraform files needed to deploy the base resource, which in this case is going to be my storage account. I am going to copy a Terraform file that I've created and prepared for this webinar. I'm going to cat back to files and main.tf, and we will just copy this right here. So going through this Terraform file briefly, what we're doing is we're creating an Azure resource group, and then we're using a Massdriver Terraform module for a generic storage account. I then went ahead and added some additional properties, specifically these queue properties, that an Azure Queue storage account would need instead. If you know Terraform, that's great. It'll be quite easy to make bundles. If you aren't too familiar with Terraform, that's okay too. All of our Massdriver bundles are open source, which means that you can copy and paste any of the Terraform in there that might help. We also have a growing community Slack channel where some customers and even Massdriver employees may be able to help you out with some Terraform questions. Now that I have the main.tf file set up, I'm going to go ahead and modify my providers file. We're going to chop out what we don't need. So I don't need anything for Kubernetes or Google. I don't need anything from AWS. We're going to uncomment the Azure components. Same thing down here. And we'll just erase these components and uncomment this. So if you're unfamiliar with the providers file, what the providers file does is it basically says that Terraform is using this version and it's connecting to this, this resource type. In this case, it'd be Azure RM, which is the Terraform provider. And then I'm telling my Terraform provider where to find the values to authenticate to Azure. In this case, I'm routing it as variables. So now that we have the providers file set up, what we're going to do next is modify the massdriver.yaml. But before we can do that, we need to get a basic understanding of what the massdriver.yaml file does. So I'm going to go ahead and switch back to my presentation here. The massdriver.yaml file is responsible for the configuration page of your bundle in the Massdriver canvas. All of the options that you get to select in the UI are created here in this file. There are three main components of a massdriver.yaml. We have the params, which are configurable options. We have connections, which are the dependencies. And then we have artifacts, which are the outputs. All of these three main components are stored as JSON. To ensure that we have the proper JSON structure for these three components, Massdriver uses JSON schema. JSON schema allows you to define the structure of a JSON object with either JSON or YAML. Let's look at a couple of examples here. The top example shows the JSON schema, and the bottom example shows the JSON object. The schema sets the structure for the object, and it's stating the field named hello, and it contains a string, and another field named age that has an integer that must be greater than or equal to 0. I'll leave a link about JSON schema here in the chat if you wanted to peruse. Paste that in there. So now that we have a very, very basic high-level view of what JSON schema is, let's see how it is used in Massdriver. We're going to open up the massdriver.yaml file. And as we can see, it's just regular YAML here. As I mentioned earlier, the params section right here on line 11 of the massdriver.yaml file defines the bundle configuration fields in the UI. This is because the JSON schema can be rendered as a web form. By writing JSON schema, we can add configuration fields, we can remove configuration fields, and we can even enforce validations on those fields. In the Massdriver UI, when you click Save or Deploy, it creates a JSON object that matches the schema, and it will be passed to the infrastructure as code during execution. I want to create a param here that allows my users to decide what region they want to deploy their storage account to. I'm going to make a region block here under properties. I'll just rename foo to region. And we are going to set a title of region, a description of region of my storage account. And then I'm going to erase this line, these lines here. So what I have available for regions is a reference pointer. So this reference pointer here acts, it points to an artifact definition type that we have created in Massdriver specifically for Azure regions. It will query your Azure account for all of the available regions and then list them in the UI. I'd rather do that instead of setting up a static string. And since the type is included in the ref pointer, I'll go ahead and remove the type. And then the last thing that I want to add to the region is a custom field called md.immutable, and we'll mark this as true. So the md.immutable field makes it so once your bundle has deployed, the param cannot be changed. Only decommissioning the bundle unlocks that param. If we did not have this in place and someone deployed my Azure Queue storage account and then changed regions after it's deployed, it would actually destroy the storage account and then recreate it in the new region and all the data inside as well. And now what we want to do is we want to make our region field required. I'm going to go ahead and erase these examples here because we don't need any preset configurations, and I'll just set an empty array bracket in its place. I also want to scroll down to the UI block here. So this UI block controls the ordering of the params above. And I'm just going to add region. So adding this isn't necessary, but it is helpful for organizing. Once I add more params down the line, having this in place will let me order my params in a logical order that makes sense. I also want to add a widget, a custom Massdriver widget to this block. We're just going to do region, and then we'll do UI field supported cloud locations dropdown, and then we'll set the cloud service to Azure. So what this does is this is the custom widget that works with our reference pointer to populate that dropdown with the Azure regions that are applicable. The last thing that I need to do here is set the bundle type. And we'll do that up here on line 7. Our bundles support 2 types, infrastructure and applications. Since I'm building an infrastructure bundle, I'll set this to infrastructure. Should spell that right. The application type would be used for application runtime templates, which allows more flexibility in the file components for things like environment variables, secrets, and IAM policies. Great. So the last thing that we need to do here, now that we have our bundle built out, is run in the terminal here below, mass bundle publish. What mass bundle publish does is it'll publish your bundle to your private organization, meaning only your organization will have access to use this bundle. We'll do mass bundle publish. And now it's hydrated a lot of additional files that I could use for local testing if I wanted to, but it has published to my Massdriver account. So I am going to switch to Massdriver. And thank you, Corey, for posting that list of custom widgets. And I'm just going to refresh here. No thanks. I'll start with infrastructure and we'll look for a queue. And right here, we have my Azure storage account queue. We'll call this queue and hit submit. So I searched for queue. We saw it pop up. We can tell that it's a private bundle because my personal org slug is in front of the name. It's in the prefix of the name of the bundle instead of Massdriver. If we look at the bundle above, it says Massdriver / AWS, blah, blah, blah. You'll find that all official Massdriver bundles will have this Massdriver prefix on top of it, which allows us to determine which bundles are private and which bundles are officially Massdriver. Okay, so now let's go ahead and click configure on the storage account. And we see the region field here. I'll click on the drop down, and here we have a populated list of available regions for my Azure account. I'm going to select West US and click deploy. So we can see that it's starting to deploy here. This will take about 60 seconds to come up. While we're waiting, I'm going to go ahead and close this out here. I can always resume looking at the progress of my deployments by clicking on the progress button. That'll bring the drawer back out. But I'm going to click out here, and we're going to take a look at this bundle bar, and I'll filter for infrastructure. So you'll find that this bundle bar contains all of the Massdriver bundles as well as your private bundles. You can think of this as like our marketplace. We have about 70 official Massdriver bundles so far. The cool thing about our Massdriver bundles is that they're all open source, which empowers our community to contribute to the bundle repos, as well as fork the bundles into your own GitHub organization. And what you can do is you can modify them and publish them as your own private bundle. You don't need to build every single bundle from scratch. Okay, so now that our bundle is deployed, we can tell by the green check mark up here, I'd like to add a new param to my bundle. Let's switch back into VS Code and we'll take a look at main.tf. Right now, we're hard coding the retention policy under logging to 30 days, but I'd like to expose that as a parameter that users can modify. So let's update this Terraform here. We're going to set this to var.retention policy. Great. So we have the variable set in the Terraform. What we need to do now is add the Terraform into the massdriver.yaml. So under region, we're going to create a new block, and we're going to call this retention policy. And then we're going to tab in. We're going to add a title, retention policy. Oops. We're going to add a description, set logging retention policy. We're going to set a type This type is going to be an integer because it expects a number. And then we need some constraints and validations for our variable here. Now, reviewing the Terraform for the Azure Storage account, I know that this field has a minimum value of 1 and a maximum value of 365. So I'm going to set these values here so that my users don't feel the pain of deploying with an incorrect value. I'm going to set minimum of 1, maximum 365. I'd also like to set a default value here. If I set a default of 30, this will act as a good starting point. It'll populate the field with 30 for me, but that doesn't mean that I can't change it. And then what we want to do now is set retention policy as a required field. So we cannot deploy unless we've set this field. Awesome. Let's go ahead and type mass bundle publish again to publish our changes. And that went through. And we'll switch to Massdriver and we'll refresh here. So after refreshing, we see that there's this little orange icon here on the bundle. This tells us that there's an update available for the bundle. If we click configure, we should see the param here. The retention policy is now available and it's set to 30. Let's go ahead and change this value to 60 and redeploy. This should take about 30 seconds to deploy. I'm going to go ahead and let it run in the background. And what I want to do now is create an artifact output for my storage account so that downstream bundles, whether it's infrastructure or artifacts, can connect and use my storage account. As I mentioned earlier, the artifacts create connection rules for the bundles. So what we're going to do now is create the artifact labeled Azure Storage Account Queue with data on how to authenticate to the storage account using RBAC. Let's go ahead and dive in here. So we're going to switch to the artifacts file. We have a template that's already been set up and commented out. We're going to erase this template. What I want to do quickly is switch to this repo here. This is the Azure Storage Account Application Assets Bundle repo that I mentioned earlier. This is a good reference point for me to build my storage account bundle. What I want to do now is go into the source directory and into the artifacts file. And I'm just going to copy this artifacts file here and paste it right into my file. Now I'm just going to do a quick search and replace for blob, and we'll place it to queue. I've enabled matching casing, and we're going to replace. Okay, so let's briefly talk about what this file is doing. So this file is using Terraform to create a Massdriver artifact resource. This resource will specify what information is in the output of my bundle. My application will look for and use the primary queue endpoint, which is right here. It'll use that value to know which storage account to use. For authentication, we could set up static credentials if we wanted to, like an access key or a shared access signature, but best practice recommends that we use RBAC. Bundle RBAC in Massdriver is actually really cool. We know that the Azure Storage account can give read and write access. What we're doing in this file is listing those options in this security block, read and write. Either downstream resources can have read access, or they can have read and write access. When I connect my application to this bundle, I can specify in my application which permission I need of these two. Then when my storage account and application are connected together, they'll communicate. My application will say something like, hey, I need read and write access. My storage account will respond, great, I can do that. Here's the role you need, and here's the scope. AKA, it's saying, give this role for this storage account only, not for the entire subscription. The really cool part I mentioned earlier is that applications in Massdriver are really smart. Those applications have the ability to create a user-assigned identity, associate with that identity, and then assign the role available in the storage account to that identity. This process gives my application the required permissions to use my storage account. Okay, now that we have our artifact file in place, let's hop back to the massdriver.yaml, and I'll update the artifacts block to include the Azure Storage Account queue artifact. I'll go ahead and erase these comments, and I'll erase this bracket. I'm going to add a required block here at the top to basically say that the Azure Storage Account queue artifact is required. And then we'll set the properties to Azure Storage Account queue. This will open up a new block. And then what we need to do is reference a Massdriver artifact definition. So we'll type ref Massdriver / Azure Storage Account queue. So this ref, what this does is it basically sets the schema, the structure for how the artifact needs to be configured. I'm going to go ahead and post a link to our artifact definitions in the chat if anyone is interested in seeing what we have and how we build them. And then now that I have this set up, I can go ahead and run mass bundle publish again. Publish. Perfect. Let's go ahead and switch back to Massdriver. And then we're going to refresh our page again. As you can see, we have another update available. If I hover over this box is brand new. What this is telling me is that there is an unprovisioned artifact available. What I need to do to provision it is click Configure and Deploy. So we don't see any changes in the UI. There's no configuration changes that we can interact with. And that's mainly because we added a resource and not a param. To see the update, to get the new artifact, we just need to redeploy as it is. So this is deploying the artifact for us. This should take about 30 seconds to complete. While this is running, I'd like to show you where our artifacts live, specifically where your artifacts will live in your account. On the left-hand side here, we'll click Artifacts. So within the artifacts, we can view the raw data of an artifact by clicking on one of them and revealing the data. I'm going to go ahead and select my fake credentials here and then reveal some data. Excuse me. For credential artifacts, the values specified here are used to authenticate to the cloud for each deployment if that credential is set as the default credential for your environment. Bundle artifacts will output values that get injected into downstream bundles that are connected to them. If I go back, we should see some population for our storage account bundle. So we have the resource ID, we have the endpoint for the queue, and then we have the available roles and scopes that applications and bundles can use to authenticate to the storage account using RBAC. All right, we'll go back into my project here and then into my bundle building environment. And we can see that the provisioning is complete. And if I hover over this gray box, it gives us a lot more data than it did before. I have the ability to view the artifact like I just did in the artifacts page. And I can also download the artifact as raw JSON. For now, we're just going to move on. Another component that I want to add to my bundle is monitoring. We'll switch to VS Code here. I'd like to get notified when there's something wrong with my storage account. So what I'm going to do next is create a new file in the source directory called monitoring.tf. So we have this file here. We need to populate it with some Terraform. We're going to switch back over to the Azure Storage Account Application Assets repo. I'm going to go back up one directory into the monitoring, and we'll just copy this entire file and we'll paste it right in here. So this file, it looks kind of confusing. It will work as is. There's nothing I really need to change about it unless I want to add or remove which metrics to track, or if I wanted to update the default values here in this locals block. This configuration will fit most use cases. However, to make it simple, I'm going to strip away 2 of the metrics. So we're just going to erase this, and we will erase these. Okay. So what this file is doing is creating a couple resources for me. It will be creating the Azure Metric Alert resource right here, and a Massdriver alarm resource right here. These resources are going to work together to alarm me if a metric crosses a specified threshold. Now that the Terraform is added, I need to make some modifications to my massdriver.yaml. Again, I'm going to copy some bits from my GitHub repo. So I'm going to switch back over. We'll go to the main directory and open the massdriver.yaml. So the first thing that I want to copy is the params block. The params block will generate a param that my users can interact with to set the type of monitoring that they want. So I'm going to copy this monitoring block here. And then we just want availability metric alert. I'm going to add a new line under retention policy and paste it in. Awesome. So now that we have this monitoring params block, I'll just break it down real quick. What we're doing is we are exposing 3 different params: automated, custom, and disabled. If the customer or my user selects automated, it's going to use the presets set in the locals block of my monitoring file. If they select disabled, it'll allow them to customize the values as they see fit. And then disabled will just disable the alarm. It won't create at all. We need a couple more things from the repo. I'll go ahead and switch back. Another thing I need is the sorting in the UI field. We want to be able to sort our monitoring as we see fit. So I'm just going to create a new line here under region and paste in this monitoring section. We don't need this pointer. We do need this pointer here. We don't need the success. What we do need is the availability metric alert. As you can see in this UI field, I haven't really touched on this before. At the bottom of each block is an asterisk in quotes. What this does is this acts as a wildcard. So if you were to create a param and you didn't add it to the sorting list, it would just be added in the wildcard spot. If you didn't have a wildcard asterisk in this field, you would actually get an error saying that this param can't be ordered. So now that that's set up here, what we're going to do next, I believe I don't need this. We are going to copy one last block from the repo. I'm just going to scroll all the way to the top. So what this monitor alarm metric giant block here is doing is this is setting the custom thresholds for the param. So if the user were to select custom as their mode of monitoring, it'll present them with this field that they can go in and interact with. Okay, so now that I have monitoring set up, let's go ahead and run mass bundle publish again. Just going to make sure everything's added here. We do actually want to add monitoring to the required block. Just monitoring. That way that it's populated and required. Everything looks great. We'll also add retention policy here. Retention policy. So that it can be sorted above monitoring, and then we'll add monitoring so that we can dictate how it's all going to be ordered. Awesome. All right, we are ready to run mass bundle publish. And then we'll switch back into the UI and refresh. Okay, so we have an update available. Let's go ahead and click configure. We see a new param available, monitoring. If we click on the dropdown and select custom, we're presented with this custom field that allows the user to fine-grain tune how they want their monitoring set up. For now, I'm going to go ahead and select automated and deploy. So this should take a minute or two. While it's deploying, I did want to mention that we are hosting more webinars. Next week, we'll have a webinar featuring our platform diffing tool that will diff deployment histories and different environments. On the horizon, our webinars include running Azure OpenAI in Massdriver and deploying a 3-tier web application on Kubernetes with Massdriver. So I mentioned earlier that we have a community Slack for Massdriver. I'll go ahead and post a link to that in the chat. The community Slack is available for anyone to join, customer or not. We are aiming to build a community of engineers, developers, and enthusiasts who may want to know more about Massdriver or are already using Massdriver and might need some help. Members of Massdriver are in the Slack as well, so feel free to pop in and say hi. We will also be at AWS reInvent this year in Las Vegas. We do have a booth. If you're attending AWS reInvent, please stop by and see us. We're giving out some sweet Massdriver swag. You'll get to meet members of Massdriver. Our founders will be there. I'm trying to make it. Our sales guy, Lou, will be there. You'll be able to meet with us and chat about Massdriver and AWS. All right, looks like it's still taking a minute to deploy. It is deploying the Azure metric alert there. So the last thing that we need to do once this is finished is just check out how everything worked. We're going to be looking in the Azure portal and then looking at the storage account itself, which I can do now, even though metrics is still running, and then we'll just refresh in a minute when metrics is finished. So I'm going to switch to the Azure portal here. I'm in my webinar subscription, and we'll go ahead and hit refresh, and we have a resource group available. And as you can see in the resource group, we have our storage account, we have our metric rule, which is pretty much done provisioning. So I can type Massdriver. And then we have the alarm action group, which does the alerting. I'm going to go ahead and open up the storage account here. And it's just a basic storage account that we provisioned. If I open up the queues blade, we're actually going to see that it's empty. So this is an intentional design decision as we empower developers to create and manage their queues, containers, and the like using Azure's SDKs. This eliminates potential unwanted destruction of your data when changing your bundle configuration in Massdriver. And we're just going to notice, okay, so it is complete. The other thing that I wanted to show you about monitoring is that we do display monitoring in the UI. We now have this green cloud icon on my bundle. And if I click on that icon, we're going to actually see that availability of my storage account is being monitored. If at any point the metric that's tracking availability crosses the threshold that I set, it's going to trigger an alarm. What that alarm is going to do is this cloud is going to turn red. I'm going to get an email And my email is going to say, hey, Michael, your storage account, your Azure Q storage account in your webinar project for the bundle building environment is having an issue with availability. It's crossed its threshold. That'll inform me what the problem is. I can go check it out, troubleshoot it, resolve it. Once it's resolved, the metric will clear, and I'll get a follow-up email saying, hey, Michael, the metric is resolved. The alarm is resolved. You're good to go. All right. So let's go ahead and switch back here. To recap, we just created a new Massdriver bundle. We added in some Terraform. We modified the massdriver.yaml, published it as a private bundle to my organization, and then deployed it in Massdriver. At Massdriver, it is our vision and goal to make deploying and managing cloud infrastructure as easy as possible, while maintaining observability, security, and adhering to best practices. Part of attaining this goal is to make bundle building as easy as possible. We are continuously building new tooling and functionality to bridge the gap between development and operations, making bundle building a smooth and efficient process. Also, we welcome and encourage any feedback from our users, and we're always available to help with questions on how to configure a cloud resource with Terraform. This concludes our webinar. Thank you so much for joining us today. I'll be sticking around, as well as members of my team, to answer any questions that you have. If you are interested in learning more about Massdriver, please check out massdriver.cloud. Thank you.